In this video, we're gonna see this LeetCode problem, that is the +1 LeetCode problem. So if you are familiar with the arrays data structure, then you can easily perform this LeetCode problem. So it is mainly based on the arrays. So first we will just analyze the problem, and we have to approach the possible solutions for that, and then we will write. You are given a large integer represented as an array. Name is digits, right? So where each digit I is the ith digit of the integer. The digits are ordered from the most significant to least significant in left to right order. This is the kind of array that you will be given. Like this is the 1 2 3. This is the array, and you have to just increment 1 to this number. Let's say this is 1 2 3. You can see the explanation here. The array represents the integer 1 2 3, and if we just increment 1 in the 1 2 3, we just add 1 to the 1 2 3, and it will become 124. So the result should be like this, 124. So this is like this. This is a 4 3 2 1. So this is 4 3 2 1. This is the integer, and when you just add 1 to this, then it will become 4 3 2 2. So you have to just return the list like this, 4 3 2 2. Right? So if there is a 9, you can see, then it should return 1 and 0, like 10. So if we just add 1 to the 9, then surely it will become 10. So this is how you will gonna see this. So before I just go to the solution, let's just analyze. So let's say this is the array that we have. An array, this is a 1 2 3, and we have to add 1 to this number. So this is basically 1 2 3, like this, right? So this is the integer like this, and we have to add 1 to this integer, so it will become 1 2 4, right? So it will become 1 2 4. So this is the array, and this is what we have to do. We have to, the final answer should be like this, like 1 comma 2 comma 4. Should be our last final output. So how are we going to implement on this list? Let's say this is the input list, and the logic is that first let's see what's we gonna do here. This is the 0th index, this is the first index, and this is the second index. So the total length of the list is, I must say, this is the length of the list is 3. You can see the length of the list is 3, 0 1 2, right? So how are we gonna just add 1 to this? No, we have to check from the last index. If you can see here, with the last index, we say this is a 2, this is 2 index, and we can also say this is the -1 index, this is the -2 index, and this is the -3 index. So we have to check from this last index. This is this last index. If the number is less than 9, I must say, if the number is less than 9, you can see 3. Here's a 3. So we can increment only 1 directly. We can implement 1 directly, so it will become 4, right? So if there is a 5, then it will become 6. If there is 8, then it will become 9. So this implementation would be easy, and say we just have to update only the last index of the list and just return the list as it is, right? So if we, in this case, what I have to do, I have to just increment this last index, and I have to just return the list. This is the first condition, I must say. This could be the first condition. The second possibility here is that if the last index is equal to 9 or it is 0, right? If it is equal to 9, or if it is 0, then what we're gonna do here? So if it is equal to 9, or we can say if it has a 0, first we just analyze for the 9. So if it is a 9, then we have to replace it. We have to replace it with 0. Now why I'm saying like that? Let's say you have an array like 1 2 9. Let's say this is the array you have here, 1 2 9, right? So what you are gonna do, you will see that 1 2 9, if we add 1, if we add +1 into this 1 2 9, then it will surely become 130. So the final list that we should get is 130, of course. If we add 1 to this, then we surely will get 130. But how we're gonna get this 130 from this 129? The 129, if you just add 1, this will become 130. So what do you have to do? That if the last index is equals to 9, then we have to replace it with 0. So in this case, you can see the last index is 9. right? And we have to replace it with the 0, then it will become like this. So we have to just make this, if this is 9, then we have to make it like 0, we have to replace it with 0. This is the condition, and then we have to check its leading number. We have to check its leading number also. If it is less than 9, then we will implement our first condition here. If it is less than 9, then we will increment only 1. That's in case. If it is 2, then we will implement 1, we can increment 1 to this, and it will become 3. And when it becomes 3, then we will just return this whole array to the user. Right, I hope you get the point. You understand the logic behind this. So this is the thing. So we have to just make sure these two conditions like this. So just let's see how I can implement this through the code. So first what I have to do is that here is the digits list that is being given, and the first thing first, I have to just check one by one to the loop. So first what I have to do, I have to just check it from the last index, from the very last index. So first what I have to do, I have to just check the length of the list, given list, which means digits, and then I have to just start the loop from the last. So I will write for I in range, you can see n minus 1 from the last index, because if the length is 3, then it will start with the index 2, which is the last index, right? So n minus 1 till minus 1, and I'm just writing this minus 1 because it will just start with the last index. Now here it is, I've just started the loop from the very last of the index. And now what I have to check here is that if digits I, that means the last index is less than 9. If that is the less than 9, then what I have to do, I have to just increment that number I plus equals to 1. So I have to just increment that number, and what I'm going to do, I'm just return digits like this. So in this if statement, what I've just said is that I just check this condition, and what I've done here is that once I just check this condition, I just see, oh, if it is less than 9, then I will surely increment just 1, and it will become 1 to 4. It will become just 4. So this is the same condition, and I will just return the list as it is. If it is 9, then what we're going to do here, if we just digits I, we just replace that digit with 0. We'll just replace the digit with the 0, and this will go on. Like if it is 9 like this, if it just say, oh, this is a 9, then it will just replace it with 0. And now when it replace it with 0, then we have to check also the leading numbers. So that's why I just put it here, and I just keep it inside the loop. Then if it is 9, okay, then it will again run through the loop. It will again check the number, check the index, and if it is not 9, then it will increment 1. If it is 9, then it will just set it to 0. And the last thing is that what if the last condition, I must say it's not a condition, it is a thing. Like what if we have 199 like this? What if we have 199 here? So what it will gonna do here is that it will see this is the 9, it will replace it with 0. This is the 9, it will replace it with 0, and this is the 1, so it will replace it with 2, right? So it will become 2 0 0. But now what if I say here is that if we have 9, let's say we have 99. What if we have 99? So if we have a 99, then it will just replace the first thing with 0. It will replace it with 0. So these two will become 0, but at the end we have to just return additionally a 1 here, so it could become 100. So we have to check that if these both are zeros, if these both are 9s, and there are no more numbers before it, there are no more leading numbers before it, so we will just add another condition that we have to just return it with 1. We have to just add this 1 to the digits and return the list. So this is the whole algorithm that you can see here that I just written here, and let's just see if it is working. I must say it is working. Yeah, so you can see here it is working. So here you can see in the first test case run, it becomes 124. In the second test case run, this is becoming 4322. In the third test case run, you can see it is becoming the 10. So it is working only fine. And if I told you like the time and space complexity of this algorithm is that the time complexity is usually on. So we are just iterating from the last index till the first index. So the time complexity is totally based on the length of the list, which is the on. And the space complexity, I must say, if I write here, time complexity is like big O of n, because it is totally dependent on the length of the list. And you can say the space complexity is O1, and I must say it is the in situ algorithm because it uses the same list and it just update the same list like that. So space complexity is O1. We are not using any kind of additional list or any kind of things, any data structure. So this is this LeetCode problem. I hope you understand this. If you like the video, then do subscribe our channel.